mode.
Well, it's now about a minute past the half hour, so we're going to go ahead and get started. Thanks for attending. We value your time, and we'll do everything we can to ensure that it's well spent. My name's Norm. I run the sales department here at Platinum Data Solutions, and I'm going to be your host today. I have a pretty diverse background, but I've been in the technology for mortgage lending space for over 25 years. I've worked with many different technology providers. Most recently, I was with DocMagic for about 5 years. I have a strong passion for using technology to solve business issues and have had great success in doing so throughout my career. Feel free to reach out to me. You can find me on LinkedIn. My email address is below. For anybody who knows me, they know that I like to kind of start these types of meetings and things with a meaningful quote. And something came to mind recently that I think kind of illustrates what we try and do with technology here at Platinum Data Solutions. It's a quote from Arthur C. Clarke. It's, "Any sufficiently advanced technology is indistinguishable from magic." And that's kind of what we strive for here at Platinum Data Solutions, to bring meaningful solutions to the table. I feel very fortunate to be part of the Platinum Data Solutions team. Hosting these webinars is one of my very favorite things to do. We have so many subject matter experts to choose from, and there's so many collateral-related topics that the industry is kind of clamoring for that need to be addressed. And I get to give away the prizes, but more on that in a second. But enough about me. Let's talk about our attendees. We have a great turnout today, and I'm confident that you will all come away from this session more knowledgeable and better equipped to do your jobs. From that perspective, you're all winners. But one fortunate attendee will also receive a special gift from Platinum Data Solutions. This randomly selected person will win a JBL Flip wireless Bluetooth speaker. But read the fine print. You got to be present to win. So really quickly, what I want to do is tell you a little bit about Platinum Data Solutions so you'll understand how we fit into the AVM picture. Platinum Data Solutions is all things collateral and technology. And if there's one single takeaway you can take from today's session, I hope that's the one thing that you keep in mind, that we're all about collateral and technology. We've been in business for 12 years, and we provide the services in 4 basic areas. In appraisal quality, our RealView solution is an appraisal review tool. It provides an actionable, exception-driven analysis of property appraisals. So red flags pop up instantly and bubble to the top. Our clients tell us that RealView cuts their review time in half. From the risk diligence perspective, we have a product called Collateral Expert that puts your subject property into the context of the surrounding community. Are the comps reasonable considering other properties that were available? How do the subject property, the comps, and other like properties look together on a map? And does that raise any red flags? Valuation analytics. This is largely the subject of today's webinar, so I'm not going to steal Craig's thunder, but we are the largest independent provider of AVMs in the industry. So bottom line is Platinum knows AVMs and knows them inside and out. And in the mortgage services channel, these are ancillary services that we provide. We can typically beat our other providers' prices due to our volume discounts. So who is Platinum? Well, basically we're made up of 2 components, our technology/analytics and our people. We have component-driven technology and analytics that are second to none. We also have an amazing team of people who aren't just smart, they have a positive can-do attitude. And it's really the intersection of these 2 elements is what sets us apart. That's our secret sauce. Bring us your business issues and we'll put a solution in place faster than anybody else can. There seems to be a lot of confusion about AVMs in the marketplace. Some say AVMs should never be used, period. Others say that their use is appropriate with a few caveats. Well, we're here to help you make sense of that information. Platinum has a team of experts on AVMs and collateral in general. We've had no fewer than 4 subject matter experts who have written collateral-related articles in major national publications in the past 6 months. Those people include Lisa Binkley, Bill King, our CEO Phil Huff, and today's presenter. I'd now like to introduce that presenter, Mr. Craig Zelazny. Craig is our SVP of Valuation Analytics, and he runs that business channel. We're thrilled to have Craig as he brings a wealth of knowledge and experience in mortgage data and analytics to the table. You'd be hard-pressed to find anyone who knows more about AVMs and AVM testing than Craig. Craig is also the smartest guy in the room, but then again, there's just me and him in the room, so I don't know what that says about me. I'm sure you'll find Craig to be an effective communicator and an all-around great guy. Take it away, Craig.
Well, thanks, Norm. I appreciate it, and thank you to everyone for joining us today. As the title of this webinar indicates, what we're going to talk about are the best practices in building and maintaining a compliant AVM program. Compliance is a topic today that we really can't get away from. The regulators are becoming more and more interested in what you're doing and how you're doing it. So we want to go through the steps to building and maintaining a compliant AVM program. And we're going to hit on 5 or 6 key areas. One, we're going to talk about the regulations themselves. What do they say? What do you have to be focused on? What are the key components there? Secondly, I'm going to talk a little bit about testing and validation. This is an important part of understanding how AVMs work, how they perform, where you should be using them, and maybe where you should avoid them. The third topic will be AVM Cascades. Cascades are an incredibly powerful tool in the world of AVMs, and their effective use can make or break any AVM program. Fourth, we're going to get into confidence scores. And this is a topic that tends to be a little misunderstood and causes some confusion in some cases. We're going to try to clear that up for you today and give you the right background information to use them correctly. Finally, we'll talk about policies and procedures, not the most exciting aspect of anything that we do on a day-to-day basis, but a completely necessary aspect to a good program. And then finally, we'll do a little summary and wrap things up. We will field questions at the end. So if you have anything that comes up, any questions, any clarification that you'd like, you can enter that question via your webinar panel on the right-hand side of your screen. Norm will be filtering those, and we'll present them at the end as they come through. So please don't hesitate to ask. The first topic for this afternoon, first thing I want to get into are the regulations themselves. And when we talk about AVMs, there are really 2 primary regulations we want to be concerned about. One is OCC 2011-12, which is entitled Supervisory Guidance on Model Risk Management. Now, this is a broad document that really applies to all models, all mathematical or statistical models that are used in the banking industry. But there are 2 sections specifically that are most pertinent to an AVM program. One is Section 5 on model validation, which talks about the expectations and the steps that should be taken when testing and validating models, which is part of what we have to do with AVMs. And then the second thing that's important there is Section 6, which is the governance, policies, and controls section that talks a little more about the policies and procedures portion of that. Second document that's key to us is OCC 2010-42, or the Interagency Guidelines on Appraisal and Evaluation. This is a longer document, 10 or 12 pages, a lot of good information. It's an easy read, but most important is Appendix B, which talks about AVMs specifically and what you want to do to test AVMs, to evaluate their performance, to put together a cascade, to build policies and procedures, and so forth. So that's a really important one that's AVM specific. But these 2 cover all the key topics from a regulatory perspective. The other thing that I'd like to mention related to regulations is the important role that your examiner can play in this entire process. I think most of us tend to think of the examiner as maybe the guy who's trying to find a problem, who's trying to ferret out that mistake that we made. And that's not necessarily an accurate depiction. I've had the opportunity to work in a couple of different banking environments where I've been through OCC reviews and found the examiners to be tremendously helpful. They're actually trying to achieve the same thing we all are. We want a good, responsible, consistent program in place. And they're there to help. And they can be a valuable source of information around the interpretation of the guidelines and what's appropriate from a risk management standpoint in your institution. Now, rather than walking through those documents line by line, which would probably push you away faster than anything, I just wanted to hit on some of the key takeaways from those 2 documents. The first topic, or the first thought, is that doing this, the testing and the validation and following the guidelines as they're presented is a mandatory event. It's not up to us to decide whether it makes sense or not. They're there for a reason, and we need to follow those guidelines. Secondly, This is an ongoing effort. Whatever you start doing relative to the evaluation of AVM performance, the development of a cascade, putting those programs in place into production is something that has to go on continuously. You can't do it once and put it aside and say, okay, I've done my bit. It's something that you look at and you work on continuously because conditions change, the models change, testing should be done on a regular basis, and so forth. The third point that's captured in these documents is that you want to go beyond face value. It's awfully easy to take a vendor's word for their model's performance or to go to an AVM vendor and say, gosh, sell me your AVMs because I need something. The documents and the guidance are very clear that you want to dig deep. You want to kind of pull back the covers and understand the models themselves. You want to understand where the AVMs are getting their data. What kind of analytics are being employed? How are they pulling these things together? How often do they do updates, and so forth? There are a whole host of questions. But the key here is don't take things at face value. Be willing to peel back the layers of the onion and understand what's going on beneath the covers. Next is confidence scores. And I alluded to this in the opening slide. Confidence scores are an incredibly important part of AVMs and the AVM information that we get. But they're not necessarily understood very well. Take the time to understand confidence scores. Ask the vendor how they define their confidence score. Is it a forecast standard deviation? That's something that's more common. But take the time to understand those because they're a key part of a good AVM program. Next is monitoring and auditing. The documents are very clear that when you put together a program, you've got to monitor what's going on. So you may set your cascade, you may do your work and have an AVM program in place. But again, this goes kind of to the idea of it's an ongoing program. Monitor what you're doing and put in place some regular checks to make certain that the expectations you've set are being fulfilled. Make it formal. What they mean by this in the documentation, the guidance is people need to be working on this diligently. You need to document what you're doing. You need to have a formal program in place. This is not unlike what we all have to do with our appraisal programs. We have policies and procedures that define how an appraisal is used, when an appraisal is used, which appraisal is appropriate for a given risk environment. The same rules apply to AVMs. Make it formal, put it in writing, and make it part of your formal processes. And then the final point that's made in the documentation, the guidance, is that independence is a very, very, very important part of what's going on. There are a lot of different people who get involved with the use of an AVM. It's testing, it's validation, the building of a cascade, putting it in production, monitoring what's happening after the fact. These are all steps that need to be treated independently. And this is a topic that is repeated over and over again, a theme that's repeated over and over again. Maintain independence. The same person who's doing your testing is not the same person who should be building your cascade or the same person who should be using the AVMs in production. You want to keep some firewalls between those steps. So those are the key points you're going to find in the documents, the regulatory guidance. I do suggest that you take a look at them. They're not difficult reads. It will not eat up an entire afternoon. You can look at them both in less than 30 minutes. And they're very easy to read, but it gives you some key information. So now that we move past the idea of the guidance and what those regulations are telling us in a broad swath, let's talk about some of the specific steps that we want to take to build a compliant AVM program. What are those best practices? And the very first thing we need to consider is testing and validating the AVMs themselves. There are a lot of AVMs available in the marketplace. They're not created equally. They're not equally good in all situations. So we need some way to understand which is the best AVM to use in a certain situation. So let's take a step back and first consider what is an AVM. An AVM is simply a combination of two things, like most models, most mathematical models. You've got data, and in the case of an AVM, the data is typically public records information, recorded deed transactions, if you will. And then in some cases, more and more models are using multiple listing service information. They may be pulling title data. Wherever they can get information about what's happening to properties and what about those properties, characteristic information that help them better understand the relationship between those pieces of information and the value of a property they're going to go after. And then the second piece is the analytics itself, the math, the statistics. And when you combine those two things, again, as you do with any model, you get an automated valuation model. This mathematical equation that will tell you the current value of a property based on all the data that's available. So that's where we're going to start, that concept. Now, what is AVM testing? Testing in AVM consists of sending property addresses to an AVM or multiple AVMs and asking those models to value the property, and then comparing the predicted value that the AVM provides to some benchmark, some known value for the property. And in an ideal world, your benchmark value is a recent sale price. When you look at the literature and you look at the best practices in the AVM industry, we've always gone back to the idea that a recent sale between a willing buyer and seller, absent any duress or distressed environment, represents the true value of a property at that point in time. And that's what we tend to use as a benchmark value when evaluating models' performance. So that's what testing consists of. We're going to send some property addresses to the AVM. We're going to say, give us a value. And then we're going to compare those predicted values to some known sale price value or benchmark value that we have on the property. And there are some timing issues around that and so forth, but that's fundamentally what it is. Now, testing the AVM really now consists of measuring performance. So we're going to look at the difference between the predicted value from the AVM and this benchmark value, this known correct value. We're going to calculate how far off it is in dollars, how far off it is in terms of a percentage, and so forth. And that's really where the testing begins. That's the evaluation of the models. But you have to slice and dice this in a couple of different ways to make it meaningful, because no one measure of performance is going to tell you exactly how well the model performs. So not to make this a statistical discussion by any stretch, but we get into things like looking at the hit rate. How often does the AVM return a value of any type? What's the mean error? So on average, how far off were we from the correct value? We look at things like medians and standard deviations and so forth. And with all those kind of pulled together, we can get to some definition or some understanding as to how well the models performed. The other key piece to this is that when we look at model performance, we don't do it across the board straight up. We have to look at this in small groups. We have to look at it in buckets. And the most common way to do that with AVMs is at the county level geographically. County has been chosen as the basis for our evaluation because when AVMs were first created, they were powered almost solely by public records data. And when you think about the fact that public records data is recorded at the county level and that there are some differences between counties as to how frequently the data is recorded, how completely the data is recorded, that tends to make sense as to be the denomination we want to use for evaluating model performance. So a lot of different things go into that. I'm not going to go into a ton of detail, but those are the key concepts. So what does this all mean? Well, it means that if you can build a program for testing and validation that involves or includes sending out blind property addresses to the model so they can value them, you've got a good value against which to measure the model's accuracy. If you can run some statistics, some accuracy measures, and do this in a couple of different ways, look at it from a couple of different angles, you can begin to get some understanding as to how well the models are performing. So I'm going to show you a slide here. Now, I'm not going to get a big analysis discussion, but one of the things that we do with AVM performance evaluation is we look at the distribution of these errors. So if I have an AVM value 1,000 properties, and for each one of those I calculate how far off it is from the true value on a percentage basis, I get a chart, a graph that looks like this, either the blue line or the red line. This is called a distribution of errors. And I point this out, I show you this chart for one reason only. We tend to want to skinny things down to a single measure. Give me a number that tells me which model is the best. And the problem with that concept is that there is no one measure. So here we have two different models, the blue model and the red model, and they both value the same properties. You can see that with the blue line, we've got a nice tight curve. It's very pointed in the middle, it's very skinny, and most of our valuations are within 0%, I mean spot on to the true value, maybe a little bit undervalued, maybe 4 or 5% less than the true value. The red AVM, it's shifted way to the left. On average, where we get the greatest occurrence, there is maybe 15% undervalued, and we get some stuff happening up there in 15, 20, 25% above the true value. That's looking a little weird. The point here is that both of these distributions, both of these curves, have the same average and the same median or middle value. So you can't really look at any one number and say, I've got it figured out, I know the answer. Okay, so we've done our testing, and we've got some data, we've done some analysis, we've got some numbers and so forth. We want to talk about building a cascade. So what is a cascade? Well, when AVMs were first introduced, we used AVMs one-off. You picked an AVM and you ran it, and that's the value you got. The idea of a cascade came about shortly after AVMs were introduced, and the idea is that on a given geographic basis, let's just say county by county, I may see that a different model is the best model for a given county. So if I've got county A, B, and C, model 1 may be the best in county A, model 3 might be the best in county B, and model 6 might be the best in county C. A cascade allows me to break down on a geographic basis the best performing AVMs and put them in an order. So I can always be working with the best model on a county by county basis. Say, that's great, that's a great concept, but how do I know which AVM is best? Well, this goes back to the numbers that we just started talking about for our testing. We've got means and medians and standard deviations and things like that. We do have to find some way to rank order them so I know which one is the best for a given situation. And this is where we get into a little more art than science, because in order to measure the performance of an AVM and score that model in such a way that you know that you're dealing with the best, you have to consider a couple of things. One, the actual measures that you calculated for the models themselves. But beyond that, we have to match that up with the risk that's being managed. What application are we using the AVM for? Is it equity lending? Is it a portfolio? Is it a marketing program? Those are all different risk profiles. And within equity lending, you could have low LTV, high credit score lending, which is lower risk than high LTV and low credit score. You need to look at those differently, and when you score the models, you take those considerations and you try to factor them in mathematically so that you're scoring them in a manner that's consistent with the risk you're managing. It takes a little bit of practice and a little bit of thought, but it can be done, and that's the way that you build a good cascade. The reason for using a cascade is that when you break it down this way, you start to look at identifying the best model on a county-by-county basis. You don't have to worry about the fact that the one model that you think is best on average is extraordinarily good in some cases and extraordinarily bad in others. We try to minimize the variability by giving us the best on a county-by-county basis. Cascades also give us the opportunity to put 1, 2, 3, 4 models in succession. So if I've got a cascade that's 3 models deep, if I run my first model and I don't get a value, or perhaps I get a value that, well, if you don't get a value, you can jump to the second model in the cascade and run it. And if you don't get a value there, perhaps you can go to the third. Now, you can't do this blindly. There's got to be some logic behind it, some rationale, but it gives you the ability to get a greater hit rate while preserving accuracy. And that's one of the values of a cascade. But when you're going to use a cascade, and this is really common practice now, cascades are very, very common, so we want to embrace them and use them wherever we can. You've got to be aware of a couple of things. One is value shopping. You never want to use a cascade as a mechanism for finding a value that supports the deal you're trying to do or simply meets your internal criteria. You build a program independent of what you're trying to accomplish on a case-by-case basis so that it's rigorous and you're not just out there trying to find the $210,000 that make the deal go through. The other thing you want to be aware of is the level at which you build your cascade. I mentioned county as being the default. Well, we want to keep this as granular as possible. Certainly you can go to an MSA level to build your cascade. You can go to a state level. I see this done. There are situations where that's appropriate, but you want to be mindful of the risk that you're managing and whether that makes sense or not. And if you have questions, talk to somebody who's got some experience in this. Talk to your regulator, your examiner. They'll help you with this. And the third thing you want to be careful of is understanding that no one size fits all. This is not a plug-and-play kind of solution. We need to look at evaluating the AVMs on a case-by-case basis and on a periodic basis so that we're always managing the risk that we're facing and what our current production environment looks like. Now, confidence scores, I mentioned earlier, is something that a little bit confusing and a little bit misunderstood. And that's to be understood. It's to be certainly accepted because when confidence scores are first created and first released with AVMs, every model had their own definition as to what their confidence score meant. And in some cases, those definitions were helpful, and in some cases, those definitions were not so helpful. The other piece to that was that they didn't necessarily correlate well to the accuracy of the model. If I always knew that an AVM value that had a corresponding confidence score of 96 was within 2% of the true value, I'd be golden. I don't always know that's the case because that relationship doesn't always exist. What's made things a little more complicated in some respects and a little easier in others is that we've gone to this trend towards standardizing on a confidence measure called forecast standard deviation. Now, the definition of an FSD is consistent across models. However, how they calculate it and their implementation may be slightly different. And there are some things about an FSD that have weaknesses as well. So it's not necessarily a value that you can accept at face value and do what I mentioned earlier, just doing this comparison where if I get a low forecast standard deviation, then I must have a better value. The bottom line here is we need to test these things empirically. If there's a relationship that exists between a confidence measure, a confidence score of any type, whether it be a proprietary confidence score or a forecast standard deviation, we want to empirically evaluate that relationship and establish that it exists and understand what that relationship is. Do we see that there is a consistent relationship between a lower forecast standard deviation and a more accurate predicted value? If you've got that, then you've got something that's worthwhile, and you can begin to use the confidence scores of the forecast standard deviation in your decision making. And that's where this value really presents itself. As I'm looking at AVM values that are presented to me in production, whether I'm making a loan or maybe looking at a marketing program or a portfolio review, whatever it might be, if I know that I've got a well documented and consistent relationship between some measure of confidence and the accuracy of the model, then I can use the confidence score, which is presented to me at the time the AVM is run, to know whether I should feel really, really good about the AVM value, or maybe I'm not so confident in that AVM value. The point here is that those relationships, no matter how they're presented by the vendors, can vary, and we want to test those things ourselves to make certain we understand what that relationship looks like. Policies and procedures are the part of this that, depending on your area of interest, may or may not be terribly exciting, but it's a necessary component to any good compliant program. And there's one rule, and it's rule number 1, and it's rule number 2, and rule number 3. Document, document, document. No matter what steps you take to evaluate your AVMs, to test them, to look at confidence scores, to build a cascade, to score the models, whatever you're doing, it's vital that all those steps and those processes be documented. This is the first thing that an examiner will ask for when you're being reviewed. Now, as I mentioned, I've been through this a couple of times, and when the examiners come in, and you probably all experienced this, the first thing they want is all your documentation. Show us your policies and procedures so that they can read them and understand what you've put in place, and then they can review with you what you've done to make certain there's consistency between the current process and what's in writing, what the documentation says, and use that as the basis for the discussion going forward. When you get into this, you want to talk about several topics. One is what's being done. So in this case, we've got an AVM program. We are testing the AVMs. We are scoring the AVMs. We're using the scored AVMs to build a cascade. We've looked at confidence scores, and we understand that there's some relationship between the confidence scores and the model's accuracy. So we now have rules in place that say if we get a value back from a given AVM and the confidence score for a given county is below a certain level, we're not going to accept it. Those kinds of things you want to put in writing and be as specific as possible. Second thing we want to talk about is how are things being done. So this is the process. What AVM companies did you engage? What was the process for sending them data to be tested? What was the process for getting it back? How long did it take? What was your process for evaluating the models? What calculations did you do? What mathematical procedures did you use to establish a relationship between a confidence score and the model's accuracy? Those kinds of things. This is all the how is it being done. The third piece is who's doing it. As I mentioned earlier, independence is a really important part of the regulatory guidance. They don't want to see conflict of interest. So if you've got one group of perhaps analysts who are managing the data flow during your AVM testing, and they're the ones also bringing the data back and maybe doing some of the basic mathematical calculations, that's fine. But who is then deciding how those models are going to be scored for the purposes of building a cascade? Is that someone maybe in risk management, or is it someone in the appraisal group? Who's doing what, and are they independent of one another? The fourth thing that's important in the documentation is when things are being done. AVMs, not unlike other models, they change over time. Everyone's looking to get new data. Data changes based on home sale activity, listing activity. The models are constantly being updated to tweak the statistics, to tighten them up a little bit, to be as accurate as possible. So we don't live in a static world with AVMs. Testing them in January is great, but by the middle of the year, things are going to be different. The data has changed. There may be new data sources. There may certainly be changes to the analytics, to the math and statistics behind the model. So doing things on a periodic basis is important, but when you do your documentation, you need to keep that in mind. Don't just say we did it. Identify time frames. When did you send out the data? When did you do your analysis? When did you put the cascade in place? For how long is this going to be valid? Those are things that you have to address in the documentation as well. And not to sound like a broken record, but independence is key. I went through an OCC review a couple of years ago with a major regional bank, and the greatest concern that the OCC had with the AVM program was that there wasn't kind of this firewall concept that separated the people doing the testing from the people doing the analysis, from the people setting the confidence or setting the cascade parameters and scoring models and things of that nature. That was a theme that came through over and over again. So in the context of what you're doing, remember independence is key. And to that point, you don't have to do everything yourself. There are a lot of third parties out there that are able to help you. If you need third-party assistance to maintain independence, don't be afraid to seek that out. Okay, so let's go back and recap what we've talked about. some key pieces here, but nothing overly complicated. It's pretty straightforward if you think it through. One is go to occ.gov, which is the OCC's website, and the two documents that I mentioned earlier, 2011-12 and 2012-42, are the two key documents. They're both out there. Neither one are very lengthy or very complicated, but they give you some very, very important and fundamental information to how to build and maintain a good AVM program. So that's the first thing. Secondly, don't set it and forget it. No matter what you're doing, we want to continue to manage the program. It's easy to get into the idea where we've done all this work up front to analyze the models and put a cascade in place, and you finally let a big sigh of relief because it's in production, and you kind of go back to focusing on making loans and closing loans and servicing your customers. And that's a natural tendency. But these programs do change, and they require maintenance. So on a month-to-month basis, take a look at what you've done in production. Does it meet the expectations that you set for yourself during testing? Are the models performing the way you thought they would? Are you seeing anything that might make you pause and go back to the vendors and ask for clarification, or to question maybe what you did in testing? It's not a set it and forget it thing. You've got to stay on top of it. Thirdly, the confidence scores are key. This is an important piece of information that we can make great use of if we understand them. But understanding them takes a little bit of time, it takes some effort, and we have to be willing to accept the fact that in some cases we'll find great relationships between the confidence score and the model's accuracy, and sometimes we will not. One of the things that we talk about in the AVM world frequently is that testing is important because it helps you understand when not to use AVMs as much as it helps you understand when to use them. And this is true for confidence scores. If there is no relationship between the confidence score and the model's accuracy, don't force something that isn't there. Walk away and don't try to use a confidence score where there is no relationship. The fourth concept we want to reiterate is that cascades will trump a single AVM all the time. And what we mean by that is anytime you look at breaking down your footprint into smaller geographic areas and identifying the best model for that geographic area and the second best and the third best, and allow yourself to move through that cascade to find a value, absent value shopping, you're going to get a better hit rate and you're going to have a more accurate result than if you pick a single AVM hoping that in the aggregate it'll all even out, it'll all average out. Averaging is not something we want to focus on here. We want to break this down and be granular and get accurate at each small step. Fifthly, the policies and procedures. It's an important part. It's not an exciting part, but it's got to be done. The better your policies and procedures, the better your program will be, the less painful your examinations will be. And quite honestly, it gives you something to fall back on when you've got new people involved or you've got someone who may have a new idea. You've got everything documented so you can work from that as the basis for any kind of changes or modifications. This is an ongoing effort. It doesn't happen once. You can't put it on a bookshelf and go, we did our policies and procedures, and it's there under the 2 inches of dust. It's got to be something that's an active document. You're looking at it, you're studying it, you're modifying it. It's part of what you do on a day-to-day basis. And then finally, ask the experts. This is not something that we all spend a lot of time doing. I've been very fortunate to have spent a lot of time working with AVMs over the last 10 or 12 years. But if you don't have that luxury, don't hesitate to reach out to people who've got the experience to ask for help. Testing is something that is not easy to necessarily pull together. Getting good test data is not necessarily easy to do. Doing the analysis is not necessarily an afternoon's work with a spreadsheet. It's more complicated than that. It takes more time than that. Understanding how to look at the measures of performance and how to combine those into a score so that you know really which is the best AVM. These are all things that take experience. If you don't have the staff or you don't have the background or knowledge to do this, reach out to companies and people who know this area and ask for help. That'll get you to your solution the fastest way possible. So with that, I think we can move to questions and answers.
Thanks, Craig. Great job. We don't have very many questions. Feel free to ask any questions that you might have. But one question we have is, Craig mentioned the importance of understanding confidence scores. Since Platinum knows AVMs, can Platinum provide some value in your ability to look across multiple AVMs with multiple scores and confidence scoring methodologies? I think I know the answer to that, but I'll let you go ahead and tackle that one, Craig.
Yeah, the answer is absolutely yes. We at Platinum do AVM testing on a regular basis, and I manage that myself. I do that myself. And one of the things that I look at is whether there's a relationship between the confidence score and or the FSD that's being provided by the AVM and the accuracy of the model. And accuracy can take a couple of different definitions, so looking at it in a couple of different ways is important, but that's absolutely something that we do and we help our clients with all the time.
Okay, thanks, Craig. Any other questions? Okay, a couple more coming in. Will we be providing the webinar slides to participants? Yes, we can do both the slides, and we will send you a link probably on Monday of next week with a link to the actual webinar itself. It'll be available on YouTube. So if you want to share this with others within your organizations, you can do that as well. How do you cover the requirement of testing different permutations if your Cascade when data is permutations of your Cascade when data is limited?
Well, there are a couple of things there. If you've got limited data, you really need to understand what that means. And I know you're asking a broad question, but let's say that by limited data you mean in a given county, maybe we don't have a lot of properties to test. We need to be mindful of the fact that in order to understand how well the model really performs, you've got to have a large enough sample size. And this kind of goes back to the basic statistics stuff we all did in high school or college, where they talk about the importance of sample size. And there are guidelines that the industry has always used over the years for minimum sample size. I think that has to be taken a little bit with a grain of salt. It's sort of important to understand also if the area where we have a limited sample size happens to be some place where you have a lot of activity and are going to be using AVMs in that area a lot, you want a larger sample size. You want to feel better about what's happening. But when you look at permutations of the Cascade, your initial development of the Cascade is going to be a function of how you score models right off the bat. Now, one thing that you can do, and I did this when I first got into AVMs, was run a simulation. You build a Cascade, and you've got data about how each of the models is performing on a given property, and you can reorder the Cascade and run a simulation to see what the aggregate result is. So you can use tools like that to see what the different permutations look like. But generally speaking, if you build a scoring formula or a scoring approach that is consistent with the risk that you're trying to manage, you should end up with your best models being the highest score and so forth. So there should be maybe a limited need for that kind of a simulation exercise.
Didn't you mention also too, Craig, that we can supplement the client's own data with some of our own for doing some of this?
Yeah, absolutely. Data, and this is a great point, Norm. Because we do testing on our own, we have test data in a whole host of counties across the country. And if you, as a lender, want to do AVM testing, you may have data that can be combined with ours and vice versa to create a larger sample set. So an ideal place to start is first mortgage production. These are loans that are in process. They've got a contract price on them or an agreed upon sale price, but they haven't closed, so they're not in the public record. That's a great place to start. And we can look at things like that where we combine data from the client organization with our own to create a broader data set. That's a great point, Norm.
Okay. Last question I have, unless anyone else types in some more. Our regulator is requesting we include testing of